Are we
Okay,
going live
it's
yet?
gone
Or
to live.
it did? All right, maybe I could do it myself.
I
All
don't know
right.
if we're published on the page or not. I'll load that. Yeah, seems to be working.
Excellent. All right. Well, good morning, everybody. Apparently, we are live. Um, so today we want to talk a little bit about game development on Ubuntu. There's lots of different, tools and frameworks and engines and things to choose from and stuff like that when you're trying to develop a game. Um, but we have a very powerful language at our disposal. Our SDK is built around QML, and we promote the use of QML as much as possible for native applications, which is very, very, very useful. But when you're writing more complex games, you'll find yourself kind of writing a lot of the same code over and over again. So let me start out by opening up a little slide deck here and do some screen share, I guess. All right. And okay. So people usually look to game engines because they provide more complex. They meet more complex requirements for games. So things that you need to do, uh, like writing a game loop or actually directly accessing the rendering layer, so you're actually controlling the graphics. Physics engines and collision detection, sound, artificial intelligence, scripting, networking. These are the things that game developers often look look for game engines to do for them because they don't want to have to write this code over and over and over again. So many games require these sorts of things. So first you need to ask yourself, do you need a game engine? Does your game really require it? So QML is a very rich, flexible, and powerful language. You can create very compelling apps and games with it very quickly. The rapid development of QML is really a great selling point on it. So the question is, do you really need a game engine? You can do some pretty cool stuff with just pure QML. So that's the first thing you want to ask yourself. So many of these platform game engines, they provide things that are already available in QML, like sprites and some animations, particle effects, which are very cool looking, very useful in games. QML has that built in. Sound and networking components. You can access that sort of stuff from QML apps as well. So those are a lot of the things that game developers look for in game engines that are already available in QML. So if your game doesn't require any more than that, then maybe you don't need to look for a game engine and just build on the power that QML already has. But if your game is more complex, you should look at leveraging an existing game engine. So introducing Bacon 2D. A little bit about Bacon 2D. It was formerly named Quasi Engine. And Rodrigo, who's in the Hangout here, and Roger, I think is his name. Rodrigo can correct me if I'm wrong. Had developed this a couple years ago, but they kind of stopped contributing to it as much as people lost some interest. But I resurrected it when I was looking for a QML game engine to write games for in Ubuntu. And so I fixed it up a little bit and made it work on Ubuntu-touch, submitted some patches, and they were, very accepting of my patches and merged them, and we later decided to rename the project. So some of the stuff that Bacon 2D provides above and beyond what QML already provides is some basic components like game, which is the outer container for your game. We'll go into more detail about these in future slides. Scenes, so scene management, so you can have multiple scenes. A viewport, in-game entities, which are like your characters, your enemies, anything inside your game that's part of the gameplay. Behaviors, which adds some things like artificial intelligence possibilities, things like that. Parallax layers, very cool idea. You can create an image layer that is continuously moving. So like for a side scroller game or something like that, and you can have multiple layers stacked on top of each other for more of a 3D-ish effect. So you can have layers moving at different speeds at different distances. Sprite animations. So even though QML has built-in sprite support, Bacon 2D has some additional sprite animations and state changes for your sprites, so you have a little bit more control over your sprites. And physics simulations, which comes from Box 2D. So to talk a little bit about the different components built into the game engine, the game component, this is the top level container. So if you're used to working with the Ubuntu SDK, this is kind of the equivalent of a main view in the Ubuntu SDK. So you want to create this first. This defines the game. It manages the scenes, which is the current running scene. You can only have one scene at a time. It also controls the viewable area of the viewport. So we'll talk about viewports more in a few minutes, but the game defines how much of the screen you can see. And it also provides this update loop. So it goes through and on every tick of the game loop, it goes out and tells the scene when it's time to update, and the scene then updates all of its entities. So in the scene component, so you can have multiple scenes. You could think of these maybe as game levels, or maybe not. Game levels would be ultimately much more interesting to have as loadable data into an existing scene. But you could have multiple scenes, like maybe you have a scene that's a menu. So you can choose which game you want to play if you have multiple games, or multiple levels you want to choose. You could have a menu that is a scene for that, and then when you choose one, you switch to another scene. And the game component controls which scene is running right now. And only the current running scene is the one that gets all of its entities updated on the game loop. So it goes out and it knows all the entities that are attached to the scene and updates them all. So you have this game loop that runs every 30 times per second as the default, and it goes out there and updates all the entities every time and does some. We'll talk about behaviors a little bit more later, but it does some things with those, which is very interesting. And you can also set the size of a scene to be larger than the game container. And then you can control it with a viewport. So you can have a scene that is 10 times the size of your game, and then have a viewport so it can pan around. And we'll talk about the viewport, which none of this is rocket science. It's not terribly hard to do this in QML, but it's a lot simpler if we provide you the convenience functions for doing this. So the viewport allows controlling horizontally and vertically to keep the viewable area, move the viewable area around where the action is happening right now. And there's some functions for moving it programmatically if you want, but what I find most interesting is we have this Y offset and X offset properties. So you can define this viewport and then track set the offset to a player's Y or an X coordinate, and then have the viewport automatically track the player. So it'll automatically move as the player moves if you want to. And I got a little video here demonstrating that in the Pathwind game. So you'll see as he flies, if he flies too high, the viewport moves. So you go off the screen, but it just follows the player as you get closer to the top. All right. Now the entity component. This is the base of any component used in your game. So, for example, a player, an enemy, the wall, the ground, platforms. If you're jumping on things, anything in the game that you want to be something that is that other entities in the game interact with. This is the base for all entities. So you can create other components that derive from the entity and then modify it if you want. And what's really cool is you can have an attached behavior. So I think behaviors are in the next slide, but you can attach a behavior that gets run or evaluated on every update loop of the game loop. You can also override the update intervals. So if your behaviors don't need to run on every tick of the game loop, if you, like for example, if you know you only need to check your state of this certain property in the game or something every 30 seconds, you don't need it to happen 30 times a second. So you can override the update intervals so this entity gets skipped on those update checks. So it only runs every so often if you need to. And that's good for performance reasons. Why evaluate code if you don't need to? It also inherits from the Box2D body, so it provides 2D physics simulations properties to the entity. So every entity in the game has the ability to participate in the physics world, and we'll talk more about that later. Behaviors, now this is one of the most interesting things, I think. You can attach custom behaviors to entities or just have a script behavior inside your scene if you want. And then on every update loop, it executes your script. Now right now, Bacon2D only provides one type of behavior. It's called a script behavior. And the script behavior contains JavaScript that gets executed every time. And the scope of the script is limited to the current instance of the entity. So if you want to modify properties on the existing instance, it'll only affect itself. However, you can reach out and, if you want to change a property on the outside world, you can do world dot whatever and set the property, and it will change that if you reach outside of it. But by default, it limits its scope to inside the current entity. You can also, one way I use this in Pathwind is I use a script behavior to dynamically create the obstacles that fly at you. So in Pathwind, you have boxes and a guitar, clocks, all kinds of things flying at you, wheels. So I have a script behavior that runs, and on every so on a certain interval, it randomly chooses an obstacle to throw at you, and it chooses a random location to create it. So dynamically creates the entities from inside of a script behavior. So instead of writing my own timer and all that kind of stuff to automatically create stuff, I just have a script behavior running and then let the game loop do it for me. Parallax layers, very, very cool. So Bacon2D has this concept of layers in general. Right now we only have one type of layer, and it's called an image layer. But the idea of the layers is they're stacked. So you can control the depth of your layers. You can see one thing on top of the other. And the image layers can have a horizontal stepping. So you can animate them and they'll automatically move. So you can have a continuously running background, and you can also it also supports mirroring of images. So if you have an infinite scrolling background image, you need to have at each point, because it tiles the images, at each point there's a seam where it joins to the next image. All the lines have to line up. So if you mirror the images, every other image is flipped. So in theory, it'll line up very nicely. Now, sometimes if you have gradients and things like that, it looks a little bit ugly, so you have to think about those things when you're creating the images. But for the most part, it eases that a great deal. And these are also used in the Pathwind example. I think I have another little video here showing this. So this has multiple layers creating the planets and the moon and the stars. These are all on different layers. And so you can see the rocket goes in front of some and behind others, and they're all moving at different speeds. So I think this exists. This has three, if I remember correctly, 3 layers. Adds a pretty interesting depth to the game. Physics simulation. Now this is one of the coolest things. Now, the game engine provides a lot more, but it also wraps Box2D, which is a popular engine for simulating rigid bodies in 2D. It's used in many other game engines. It's very popular. So we're exposing that to QML through Bacon2D, and some of our built-in components derive from these, so you automatically get these properties like the entity, for example. So with physics properties on an entity, you can control things like contact, friction, density, restitution, dampening, motion. So you can give things velocities, you can make them bounce more, all kinds of cool stuff. So you can very, very easily create items in your game that react to other items in your game without writing all that logic yourself. Collision detection, so you could use this instead of just having objects that bounce around and fall on things and things like that. You could actually just use the collision detection to determine when things touch and do things. And you can control, you can filter those out on getting certain types of collisions. Like you only want to know when you hit an enemy, not when you hit the floor. So you can filter those out and get these nice events, which is very useful. Joints, these are incredibly cool. There's all kinds of joints built in. You can do cool things like create motors and stuff like that. I have a demo of that here coming up as well. You can also control things like forces and impulses. So you can like eject something. You can create an impulse that projects something for a certain distance, but it'll slow down based on its mass and gravity in the world and all that kind of stuff, which is pretty neat. And raycast, which is, you can think of a raycast like a ray gun or a laser. You can create a straight line between items and detect when something cuts that line. It's like a laser. You can detect when something goes through it. So you can make it do something when it goes through, like kill an enemy if a laser hits it, or you can just use it for detecting. You can have an invisible ray and see when things cross certain lines in your game. There's lots of interesting possibilities with raycasting. Here's an example of some contact stuff, and this example demonstrates a whole bunch of things that Box2D provides, and this is all running inside of a Bacon 2D game container. But as these little boxes are falling and hitting the conveyor belt, and they move to the end, their gravity changes and they get sucked up, and then they fall at the other end because gravity changes again at the other end. And the pulleys that are running the belt are running on motor joints, and the motors are powered, so they're running. There's friction on the boxes, so they stick a certain amount. There's all kinds of cool effects you can do there. Here's another example showing a stringing balls together and a cannon that shoots them, and they all kind of react to that because they're hanging and they're all attached to each other. And here's this is one of my favorite examples. So this is showing off a motor joint and friction on the tires. So you can control the torque and the speed of the wheels, and depending on the mass that the car generates, there's a different amount of friction between the tires and the ground. So you can make the tires actually spin when there's too much resistance on the car. So you'll see when it hits the end, as you adjust the torque, the tires might spin, they might not spin. So the speed is turned up there, but the torque is low, so they're not spinning. But as I turn the torque up, the wheels still spin, but there's an immovable object in front of it, so it's just spinning. So in this example, there's no code in here that's controlling movement of this car, or box. It looks more like a box in a car, but it's supposed to be a car. I'm not a designer. But it controls, what it really controls is these wheels, and the wheels, because they're interacting as part of this world, they're creating friction on the ground, it moves the car. So it makes it very, very easy to develop these kind of cool concepts into your game. So those are some brief examples of some of the stuff that is provided in Bacon 2D. And before we go on to the roadmap here, though, let's go back to the list here of the stuff that it provides, and let's see if there's anybody has any questions. So Bacon 2D does all the path for you for the physics. Well, so if I understand you correctly, what do you mean by the path? So the physics is, it kind of automatically gives you, Box2D automatically gives you all these properties in your world. So any item that you give, you make a dynamic entity in your world, and there's gravity, but your item isn't on the ground or on something that could stop it, it'll just fall until it hits something that can stop it. So you don't have to write any code to make that happen. You just add a couple properties to say, there's gravity in my world, and this is the density of my item. And you can turn up this restitution property, and as you increase that, it bounces. Oh yeah, it does all the math for you. You don't have to figure any of that stuff out. It's very, very simple. There's some link to some example code in the presentation, which I'll post this. I'll share this presentation later, and I'll blog with a link to it. So yeah, thoughts about AI. So the script behaviors that are built into Bacon 2D are primarily there actually to provide AI in your game. So you can, on every update loop, you can write a few lines of JavaScript that check the states of certain things. Is there an enemy near you? Do something. You can make it automatically do things on every loop. So you can use that for developing your own AI in the game, or you can just use it for making your own movement or whatever on every update of the game. One of our features on the roadmap that we want to work on is adding a steering behavior. So there's this library out there called Open Steering, and that can be used for a behavior that will automatically have your entity track some path. So you can make it track a path in the game already, or maybe follow another character, so you can have autonomous characters automatically. So that's one of the things we want to work on in the near future. All right, while you guys think of more questions, let's move on to the roadmap. And speaking of the roadmap, let's get Mike here to tell everybody a little bit about his Bacon 2D editor he's been working on. He posted a video of this the other day on Google+. You guys might have seen it. Mike, you want to talk about that a little bit?
Yeah, sure. So I'll show a quick demo of it now, just to sort of clarify, though it's in a very early sort of prototype stage, but you can get a feel for the sort of thing that it's going to offer. If I switch to the screen sharing, right, and start up the editor. So what we've got here is basically a Bacon 2D game element that we can drop objects on top of, and this is actually creating new QML elements inside that game that we can set running and see all the physics working. So these little blocks are little static objects, so they remain in the same place all the time, but these balls are dynamic, so they'll fall under gravity, they'll bounce into each other, all that sort of thing. So I can set that actually just running straight away, and you can see what's going to happen. You can also even drop in things whilst the world's running. That's not necessarily useful behavior, but it's interesting. You can reset the world and watch everything happen again. You can switch on Box2D's debugging mode, so you can see Box2D's representation of the world. So whilst you've got all these pretty images here, they don't necessarily map exactly to Box2D's fixtures, which are sort of defining the physical properties. So we can see sort of this ball, its rotation, it falling away, all of that sort of thing. You can drop in entities that also include behaviors. So this little flying chap has a behavior that causes, every time he flaps his wings, he gets a little impulse force that causes him to move. Now I dropped him in whilst it was running, so if I reset it, he sort of starts again from that position roughly. it's not at the moment resetting quite all of the physics properties, so things aren't entirely the same every time you restart. But it's very early days. But what's quite interesting is that you can save as a QML file. And what it basically does is it looks at the game element, it sort of introspects and goes through all of its properties, all of its children, and spits that out as a standalone QML file. So if I leave the editor and find my file manager, I can start the game completely standalone. And that's just loading that QML file in QML scene and running as a separate game completely apart from the editor. It doesn't need anything that the editor's provided. It just needs Bacon 2D. And just as a sort of separate point of interest, those entities that I had available in the editor to drag into the game are just these little QML files. It sort of scans that directory and picks up any Bacon 2D entities or Box 2D bodies that you have in your game directory and offers them for you to use in the game editor. As a sort of next step, I want to make it possible to edit entities in a more graphical, easy-to-use sort of way, but at the moment you can just sort of drop them in as pre-written bits of QML. And that's the sort of state of things at the moment. There's a lot that needs doing for it. Like at the moment, after actually dropping in components, you can't edit them. You can only drop in new ones. You can't load stuff in after saving it. There needs to be the entity editor. All these sorts of things. But the basic concept is there now, and the sort of really difficult stuff that I wasn't sure if we'd be able to do has been done and is possible. Still lots of hacks in it, but it kind of works.
To frame this a little bit, Mike, for everybody, this editor is going to be so valuable because, like for example, in Pathwind, I spent significantly more time tweaking the properties on all the entities in the game to make them behave just the way I wanted, because each obstacle, for example, needed to have different properties. Like a box rolls differently than a wheel, but it might also weigh differently. The wheel's going to weigh more. So tweaking all those things is very time consuming. You go edit a QML file, run the entire game. It's a terribly iterative process that's really time consuming. So you spend a lot of time doing that. This editor, being able to tweak these properties live and see the properties change is going to be incredibly valuable. It's going to save so much time on developing with this stuff. So great work, Mike. I can't wait to see it completed.
Yeah, thanks. I mean, it's from similar frustrations like that caused me to want to write it, because I've been doing my own sort of stuff in this area as well, and it just gets really tiresome having to tweak very tiny values to get exactly the behavior that you're looking for out of a physics engine. So I think we've had some more questions in the intervening time. So
yeah, so let's let me read these out here. So Rick had a follow-on question. He found it hard to write things like telling an enemy how to walk around obstacles and stuff. So yeah, the open steering stuff could definitely solve that problem. But there's also ways you can do that with the current script behaviors. So when the script runs, you can have it look for the look for things that you want to walk around. So like you can look for other obstacles in the world, find their coordinates, and move accordingly if you wanted to. So that's you can do that now, but the open steering stuff I think could potentially make it even easier. We'll see how that pans out when we get working on that stuff. But Rick, you could do something with that right now with the script behaviors. So the Can you add new components in there? I think you already answered the next question about adding new components in the editor.
Yeah, so at the moment it's a sort of slightly manual process in that you have to write the QML components yourself, but it automatically picks them up. But in the future, it's going to provide a nice editor to create the components as well.
Right. So, and there's also this build question. Yeah, so it uses a submodule, so you need to, I don't remember the command for this. Maybe Rodrigo can type it in here. I'm terribly dense when it comes to Git. I really am not a big fan of Git, but it's very handy to be able to use these submodules. So it pulls in a submodule for QML-Box2D. So you need to init that so it'll actually fetch the branch. And then you need to make sure you delete everything in your build directory and start over, rebuild again, because I think it fails again even if you initialize the submodule. Yeah, there it is. I knew Rodrigo would know. Well, let me skip the performance one here and go to the next one because I read it out of order here. So the supporting other platforms, that's a great question because Pathwind, I have Android builds for that. I haven't published it in the Play Store yet, but I keep meaning to do that. It's just Android stuff's always, I don't get around to it that often. So, but it works very nicely on Android as well. And the great news is there's actually only a few lines of code difference between my Ubuntu branch and my Android branch. So for Pathwind, and really the only change is in the Ubuntu version, I'm using the orientation helper from the Ubuntu SDK to lock it in landscape mode. Which of course doesn't exist in the Android side, so I can't use that on the Android side, but I don't need to on the Android package because you can define that in some of the Android metadata stuff, one of the XML files. You can say you want it to be a landscape, and it automatically goes to landscape. So there's only a few lines of code difference, and that's just to lock it into landscape. Otherwise, it's exactly the same, and it just works. So it's very, very cool. In theory, it should be able to work on iOS as well. I understand there might be a few build-related issues we might need to work through if we really wanted to get builds working on for iOS, but it's not insurmountable. The Qt stuff is cross-platform and should work nicely there. So the question about performance of the scene and that it's using a quick painted item. Yeah, so that some of that stuff that's using the quick painted item was there for the port from Qt4 to Qt5, and Rodrigo right now is working on rewriting some of that stuff to use the scene graph, like the image, particularly the image image layer. I don't think the entity is using quick painted item though. I think that's just a quick item, if I recall correctly. But the tiling stuff and the image layer and things like that is definitely not the most performant for that reason. And Rodrigo's working on fixing that for us now. So let's look at the roadmap a little bit more. Some other cool stuff that's kind of in the works. We have a branch that can load a TileD map. I'm not sure if everybody's familiar with TileD, but there's a pretty common map format for games for creating maps. Called TileD, and there's a program out there for creating these maps called Map Editor, which is actually a Qt app, but it's cross-platform and it's widely used. You can look at it at mapeditor.org. But we have a branch that can load one of these .tmx files that provides all the vector information for setting up your scene. And it can contain everything that needs to go into your scene. It doesn't work yet, but it reads the file. So it's in the process right now. We're working on it. So that'll be a cool addition, I think. I want to do as much as I can to split out content and game. Well, I guess content's the best way to work, but more and more stuff out of the code. So like the ability to loading and saving of game levels. So maybe creating a game level that is inside of a scene, but has information about like how do you build this level. Like maybe it's a map, or what entities are in this particular level of the game. Maybe that could be saved off in like a JSON file or something like that with all the vector information on how how to set up the level, and make that a bit more dynamic. So maybe you could save a level and share it, things like that. So I'd like to split that out a little bit more, but I haven't really started investigating that yet. The steering behaviors, I think that'll be incredibly useful. So these are some of our shorter term goals we want to work on. Let's see if there's any more questions. All right. You guys, anybody have any more questions? Anybody want to see a little snippet of code, maybe? Let me do a completely unprepared little demo, I think. Hang on a second. I'll show off the code for this car example, I think. One second. Sorry, had to copy it from my other computer. All right, and go to the all right. So here's the code for that car example using the motor joints for the wheels. So you see there's the game outside. Actually, there's a rectangle there too. The scene, and then there's the Box2D world inside of that. And inside the world here we have walls. So we create 4 walls to define the outer edges. And then a Box2D body for the ground. A canvas to draw in that little bump in the middle of the screen, a little ramp that it goes up and down. Here's the body for the car. And see, it's got a fixture of this box. Now, this the Box2D fixtures, Box2D doesn't provide any visual elements. So this is a virtual box. It's the coordinates for the fixture. This is where the collision detection is going to happen, and you want to attach this to a visual item. So, for example, here we fill it with a rectangle that's orange. So, and then we anchor them the same, so they should track. But that box itself isn't a visual item. You don't see it on the screen. And here's a wheel, and wheel A and wheel B, and then you'll see here there's a wheel joint. So this wheel joint connects the body to wheel A, and there's 2 wheel joints. So one connects to wheel A and one connects to wheel B, and it sets the anchor points, so you can see where they are anchored. And you can enable the motor to turn it on and set the motor speed. So here we're setting it from a property that's set outside. So we have the little slider to control the speed and the torque. Okay, so this is essentially a wheel powered by a motor, and we can control the properties of that motor. And you'll notice up here, if you look at the wheels, there's things like friction. Density weighs in here because it helps create the mass, how heavy the thing is. And if we reduce this friction amount, you'll see more spinning of the wheels and less movement of the car. So you can adjust all those properties. So just by tweaking a few of these properties, you can dramatically change the movement of the item on the screen and how it behaves. So all this physics stuff that's built into it, it's so simple to create this stuff in your game using QML with Box2D at your disposal. So you can do really, really interesting stuff. So you have any more questions here? There's some more here. You can let Rodrigo answer the OpenGL stuff. So I haven't looked at anything for 3D games. I mean, Bacon 2D is purely designed for 2D stuff. There's a whole new level of complexity if you want things to have 3D properties. I like Rick's question, can I quit my job and write games for Ubuntu-Touch? No, Rick, you cannot. I'm not sure what an NDR framework is.
That's something that Mike Hall's been working on. It translates the Android XML stuff to sort of QML elements.
Right. Yeah. Okay. I remember now. Yeah, I don't know how that would work with games because the games are generally much more complex code for Android. They're all using different engines and things like that, like Unity 3D and things like that. So, and the code for all the examples is available. There are links in my presentation in the slides, which I'll be sharing later today. But they're also all in GitHub. Actually, the car example might not be in GitHub. Maybe I'll add that. But yeah, all the example code's available. Another thing that Rodrigo and Roger have been, I think, kind of working on, but we haven't touched it in a while, is a texture packer. If I'm not mistaken, Rodrigo, where you can create texture packs for your game and load those. Would be interesting. All right. Well, I think we are about out of time. So thanks, everybody. You can look for. I'll post a blog post later today, and it'll show up on Planet Ubuntu with links to the slides. All right. I hope everybody goes out and creates some very cool games.